This one, they both have a positive, so instead of canceling out, there end up being two of them. So when the signs are different, that's what gives us that difference of squares, because you'll get a plus xy and a minus xy, and they cancel out. On this one, they're both the same, so instead of canceling, they get added together, so we have 2xy. So as I'm factoring each part of this, here's my difference of squares. This one can't be factored, I just copy it down. Here's my difference of cubes, and this one is that perfect square. So it's x plus y, x plus y. And then just cancel out anything you can. Yay! That just caused more of it to cancel out. Were there questions other than 21?
29.
29. Do you have the problem out?
Yeah.
Can you read it?
X squared minus 16, that's in parentheses, over 3x minus 12, parentheses, times, oh wait, that might not be right, because I think
it was divided by, and I think you flipped it.
Yeah,
already.
I think I already did that.
Which one are 21? 29.
29.
Divided by 3x minus 12. But you shouldn't have to do 20 of those. On every other odd? Is it 21, not 23, 25, 27, 29. Exclude my exclude. Alright, so I'm going to go ahead and factor what I can out of these, because they're not going to get flipped anyway. So that top one, that's the difference of squares.
I think you forgot to rewrite
That's not the right problem.
3x minus 12.
I think it's not the right problem.
You forgot to do
I wrote what you told me to write.
x squared minus 10x plus 2
Okay, she didn't
25.
help me.
No, you had it all right.
No,
Except for one number. It's x squared minus 16.
I don't trust you.
Fun!
I still like you. Does that count for anything?
No. Just kidding.
Yes.
Well, maybe New World?
Unrelated. Okay, here we
That's a
go.
good one.
This one still is a difference of squares, so it's still x plus 4, x minus 4. This one on the bottom, I need two factors of 25 that give me negative 10.
You didn't flip them.
-5 and -5.
Negative 5 and negative 5, you're right.
Thank you.
This is number 29. It is? Okay. Alright, now I have to flip this fraction, because remember you do times the reciprocal. So the 3x minus 12 won't be on the top anymore, it will move to the bottom. But I can take out a GCF of
3x minus 4.
and this x squared minus 3x minus 10 won't be on the bottom anymore, it will move to the top. But let's factor it and find two factors of negative 10 that give us negative 3.
-5.
2 and negative 5.
Negative 5.
All wrong.
Okay, so now we're going to, remember that to multiply we just combine everything into one fraction bar, but I'm not going to rewrite it. They're all in one fraction bar.
And then you just cross out, right?
Yeah, whatever.
I just wanted to make sure I did it right.
Is that it? So
I was confused by what you do with that 3 on the outside.
just write it down.
Okay.
Usually you put it in the front just because it looks prettier, but it really doesn't matter if it's on the front or the back. Can you do number 33? Because either I'm doing something way wrong or I don't know. It's probably not way wrong. You'd be surprised how a little wrong can make it look way wrong. X times X plus 1. They're trying to trick you on this one all the way to that. Yeah, I plus 1x plus 2x plus 1. Okay. What they want you to do, they're tricking you, and they know students. So they know that what the first instinct you have is to go, oh, x plus 1, x plus 1.
That's what I did.
Do you know why?
Because you have to.
Because it's a subtraction problem. We can only do all that canceling when it's all multiplication and division. So it ends up being a little longer problem than that. For just a minute, I'm going to work just with the numerator. So I don't have to rewrite the denominator every time. But you have to multiply it out, x squared plus x minus 2x minus 6. So I've just done x times x times 1, negative 2 times x, negative 2 times 3. Putting together the like terms and factor that new 6.
Oh, okay.
So 2 factors of negative 6, that gives me negative 1. That would be x minus 3 and x plus 2. And then for a minute I worked with just the numerator. Now I'm going to put the denominator back on. 1, 2. They tricked you on purpose there, because they knew you would do it. So the x plus 2's cancel. These don't. They are not the same thing. And on the bottom. But sometimes it's good to be tricked on homework because it means maybe you won't be tricked on
The first time I did that. The second time I did it, I got to that x squared plus x whatever that I didn't know. I forgot to combine the like terms and I didn't know what was going on.
Yeah, because it has 4 terms. I want to do something right here. I put the like terms together, but what if you just saw the 4 terms? What if you multiply that out and saw 4 terms? How do you do it if it has 4 terms? Split it in half.
Oh,
So
yeah.
take out a GCF, x plus 1. Take a GCF out of here. Oh no, you just get back to there.
Oh.
Sometimes it'll work out. Sorry. Sometimes it does. Anything else from this stuff? I feel like you got the basic idea really well, but it was just the little details that got a little tricky. Alright, then let's pass those up, because we got to do some addition and subtraction, and that is the stinkiest one of the whole bunch. But once it's done, you're asking for it.
I don't know. I didn't.
Well, it was like during the summer a long time ago. It was like what we ready to
Stop it.
wake up.
No, I'm
No, it was
tired.
just like no,
I want to go back to bed.
They have some cake, but they don't have cake that's good about that.
Do you have any characters in your history reading again? Because I didn't. All I had was a summary.
Specific cake, I feel like I should get.
Oh, I didn't put them in.
That first one,
Sarah.
I didn't want to do it, but I felt like we needed to do at least one of those.
I just did a summary. But I had a good detail summary.
Okay. Now we gotta add on This one is the worst. I'm gonna lay it out for you, I'll be honest.
Oh, keep bringing my paper. I have paper.
Alright, I'm gonna look at, this is technically a rational expression, right? It's a lot simpler than the ones we've been doing the last couple days, but this is a rational expression. So what we did in section 1 is we just learned to simplify. We rewrote it, basically we factor it, and cancel out what you can.
Oh no.
So we've simplified, that's what we've already done. Now, yes ma'am? We're on 62, which is page 250. What we're going to do now is a little harder. And it's real easy. Think about this. How do you multiply a fraction like that?
Just across the top.
You just multiply across. Easy, right? That's what we did yesterday too. We just multiply straight across. When you divide, you just multiply by the reciprocal. Those are easy. Now remember, we're doing fractions. Is that as easy? Can we just go straight across? No. What do we have to to do before we can add or subtract. A common denominator, what should our common denominator be?
12.
12 is a good one. You can always multiply the two together. Always. So here we multiply the top and bottom by 4. And that gives me 4/12. Multiply the top and the bottom by 3. And that gives me 3/12. And that's 7/12. But keep in mind that what we're doing now is not little fractions like these. Beautiful algebraic fractions. And we still have to get a common denominator because they're still fractions. No. Three. Oh, does that have one that does already have one? 3 plus x over x and 4 over x. The first example I do is one that already has a common denominator. See, they both have x. So now what do we do? If they already have a common denominator, then my common denominator is
X.
So the answer is just going to have x. Just like here, you go to all that trouble to find the common denominator, you keep it in your answer. Because it gets confusing when the numbers get there. So they have a common denominator of x. That's what goes with the answer. What do I do for the top?
Add them together.
You just add them together once we have a common denominator. And then we simplify it if we can. So that would be 7 plus x over x. Or x plus 7, the order of those doesn't matter, that's the commutative property. Can we cancel those x's? No! Why can you not cancel the x's? The plus there is joining them together. Think of them as married. We cannot separate this x from his 7 till death do it.
Or eraser.
That kind of outside the box thinking for an American Dad.
I'm glad I'm contributing.
Here's one. Unlike denominator. 7a over 8. Oh, they're giving you easy ones. Plus 5b. They do a lot of them with common denominators. There are a lot of examples in the book. 3 examples plus 2 more to try by yourself. They're really just addition if they already have a common denominator. These do not have a common denominator. Now, in our dream world, we would always like to have the least common denominator because it means we won't have to simplify things later. But you can always multiply those two things together and use that as your common denominator. So if you're not good at getting a least common denominator, who cares? Just get a common denominator. So you could use 96a as your common denominator. Where did that come from? 8 times 12a. Multiply the two.
Or 24.
What do you do to the top?
Yeah, 24x would be better. So what we do, if we're trying to get the least common denominator, first we look at the letters, and for this one we just need the a. And then we look at the numbers, and we treat them as if kind of the letters weren't there. What's the least common denominator for 8 and 12?
24.
24, because that is the smallest thing that both 8 and 12 will go into. So we're going to use 24a as our common denominator. What did I have to multiply this by to get 24a?
3a.
3a. So that's what I have to multiply by on the top. Alright, 3a times 7a makes
21a.
21a
squared.
squared.
If you did the 96 route, what would you do to
You
the top?
multiply this by 12a. And you multiply this by 8.
Okay.
You just multiply each one by the other. But you'll have, if you do that, that's fine, but you'll have more simplification to do at the end, which is also fine. Alright, what did I have to multiply that by to get 24a?
2.
Times 2, so I do times 2 up here, and I get 10b with a plus sign between them. Why is there a plus sign between them? Because there was a plus sign right here. If there had been a minus sign right here, I would put a minus sign right there. Yes, Margaret?
I thought we were allowed to multiply like a regular number with a number of zeros.
You can multiply anything. It's addition that's strictly. You can't add, like these two cannot be put together because one has an A and one has a B.
When we were doing multiplication, everything, they had to have the same.
Addition, they have to have the same. Just like they have to have the same denominator before we can add them, they have to have the same variables before we can add them, that you can multiply into. Alright, let's take a minute and pretend we're not good at common denominators, because a lot of people aren't, and I don't want you to feel like you can't do these. So, let's say that we chose to use instead for our common denominator 96a, which came from just multiplying the two denominators. Then I would multiply this one both by 12a, because I got it from right here, and I would multiply this one by 8, so I would get 84a, is that right?
Yeah, squared.
And then over here we get
40B.
40b. And then the problem is those are going to have a greatest common factor that I need to take out. And that greatest common factor would be 4.
Sure. Well, there you have it.
That's not right.
It looks right.
And then 96 can also be divided by 4. So that's when it becomes what we had before.
Wow.
Yeah. Or was it 24? Because I divided both the top and the bottom by 4. It can still be done. It actually ends up being longer. It's easier to get the factors out here than there, but it still can be done.
She's done.
Wait, where'd that 4 go?
I canceled it with the 96. I divided this by 4, and I divided that by 4. So if you choose to not use the least common denominator, but instead to use another one, you will have a GCF that you need to take out and cancel. That's what happens when you didn't get the least common denominator. It's not over, you didn't mess it up, you just have to take out a GCF later. Yes, ma'am. If you don't want to have to do the greatest common factor later. Yeah. Alright, let's try it again. Whatever 2x. Yeah, but it's the same. The only difference would be instead of a plus, there'd be a minus. So instead of a plus, you write a minus. Same problem. Like, as far as the actual work goes, it doesn't really change anything. 1 over 2x plus 5x over, or in here. Got 3 of them in here. 3 over x. Look at that.
Fun.
Alright, to get a least common denominator for these gorgeous gems, what we're going to do is factor each one if we can. This one is not really, 2 times x, but that doesn't do us any good, and neither is this one, but this one can be. What's another way to write x squared minus 1?
X plus 1, x minus 1.
That's right. Now, our least common denominator has to have everything represented in there. So we have to have a 2 because there's a 2. We have to have an x because here's an x. We have to have an x plus 1 because here's an x plus 1. I know it looks like we're not getting anywhere, but we are. We have to have an x minus 1 because here's an x minus 1. We have to have an x plus 1, but we already have it. So there's our least common denominator.
So you have to have
That
each
makes sense?
variable.
Everything has to be represented, which is really the same thing we did here when we got our least common denominator. Because 8 is 4 times 2, and 12 is 4 times 3 times 8. So our least common denominator was, we have to have a 4, we have to have a 2, we already got this one, we got to have a 3, we got to have an A, and that comes out 24A. That's what we did when we got that least common denominator. We make sure everything gets represented. Ooh, look how long that is in the book. Alright. What did we multiply 2x by to get that?
X plus 1, x minus 1.
So we have to do that on the top as well, 1 times x
What the
which
heck?
luckily is just still. Okay, now, what did I multiply this by to get that?
I have no idea.
2x.
Wait, say this again?
What did I multiply this denominator by to get our common denominator?
Okay, that makes sense.
2x. So we'll have to do the same thing on the top, which will give us
10x squared.
10x squared. So I'm writing 10, a plus 10x squared. Why plus? Because that's a plus. Alright, what did this get multiplied by?
2x.
to give
X
us
minus 1.
2x
Sorry.
x minus 1. So the 3 has to be multiplied by that. So that makes 6 times 2. Wait, no, I already did the 6.
Wait.
Yeah, so 3 times 2, that's the 6.
Okay, now,
X,
okay.
X minus
Okay, alright.
Wouldn't it be awesome if we were finished? Are you kidding me? We're not.
Wait,
You can
You just have to simplify it now.
It's not in simplify.
wait,
Is there really one?
would you multiply the 3 by the x minus 1?
You can get rid of the x plus 1, x minus 1.
You can divide
I
that 6x into 2x?
I'm having
Okay,
trouble
so
with
it's
this.
No, no, you
Right.
can't.
Time out. Let's make sure we get all the questions about how we got this before we move on to what.
Okay, so I get, on the last one, I get how we get the 6x, but, do we not multiply the 3 by the x minus 1? We did, keep it. Will we not multiply it through? Wait, I'm confused.
Like we will, but not yet.
Okay.
I just kind
I
of
need to
did
do
the
a
3
lot
times
more of
2
these.
times x minus 1, and that's what we have to do next. So you're on the right track.
No. No.
Alright, this can be simplified.
Okay, now I get
So what we have to do is, we need to simplify this numerator. So again, just for a minute, we're going to work with just the numerator, because that's where all our work is going to have to go right now. We have to do x plus 1 times x minus 1. Luckily, we know that that's x squared minus 1, right?
Oh, wait,
That
what'd
was the
you do?
difference of squares. And then x plus 1 times x minus 1.
You
Why
did
can't you
wrong
go ahead and
there.
simplify them already?
Hmm?
Why can't you simplify them?
Because of these pluses. Sorry. I mean, I wish I could make it not like this, but I can't. I told you this one was the worst. You would think division would be really hard, but I think you're going to like that one.
Great.
So if we can get through this one, you'll like division.
So you put the x plus 1 and x minus 1 back into how it was?
Oh.
Alright, and then 10x squared, I just copied, there's really nothing I can do with that one. But I can distribute this 6x. So 6x times x makes,
6x squared.
and 6x times negative 1 minus
Negative
2.
6x.
Alright, now, let's put together our like terms. So we have x squared and 10x squared and 6x squared make
17x squared.
1x squared. Wait, that's not what they got. It is.
Minus 6x minus 1.
Over
2x.
x plus 1.
But then you can't even cross out anything.
Isn't that depressing? Now, I think this is where they were mean to you. Sometimes you can. Like, because you can factor this little trinomial, but this one just happens to be prime. I don't know why they chose that as an example.
So what do you do now?
You're done. You did it.
That's stupid.
We did it! Wasn't it
We
awesome?
did it. We did it. We did it.
You get to go
and
chocolate everywhere.
Sometimes they do, sometimes in the back end, and then you can't. And then that whole big other thing reduces to a little, I wish they had done that.
Not abominable, it's abominable.
It's
I'm taking Spanish, it's abominable.
It's bomb.
She's dumb.
They just
Yeah.
abominable.
Sorry, I
You thought it was Bominos?
Wait,
Bomino.
It's Bominos.
B-A-M-A-N-O-S.
So you pronounce the B with a D?
Abominable. No, you don't. Oh, you don't. You don't say abominable.
Here's the deal where it's right. I'm gonna do one example, and you're gonna be very quiet and participate.
Thank you.
And if you do, then, you gotta try one. If we do, I'll just give you the one problem. If I have to ask you to be quiet during this last example, you're getting my original assignment, which is terrible.
Bring it
But it
on.
is.
No. I do not want to bring it
Divide
on.
and flat.
Oh, need a home.
Bless
Thanks. This one's a minus. Can this be factored?
No.
No.
Can this be factored?
No.
No. So what we have to do is just use it. Is that A minus 4? Yes. The A plus 3 has to be represented in my least common denominator. The A has to be represented. So there's my least common denominator. This one's not bad.
Is that A minus 4 on top?
So I have to multiply both of these times the times A, and that's A squared. I have to multiply both of these times A plus 3. So that would be
A squared, negative A, and then negative 12.
right. We're very good at doing
Okay.
this in your head.
Wait, what did he do?
He spoiled them. He multiplied them out. A times A is A squared. Then A times 3 is 3A. Negative 4A. Minus 12. And he put the like terms together already.
Okay, I was like, what?
I know.
He's just being silly.
Can we
But
write
this
that
is
out
being
then?
subtracted, so we have to be careful how we write it. We write minus A squared plus A plus 12. Because all of that was being subtracted.
Can you write that all out? I know he's amazing because he did it in his head, but
This.
I think he's really bad.
I thought it was minus A squared minus A. Oh, because you distributed your negative?
This for you, Alicia.
Thank you.
We multiplied it out, and then when you put the like terms together, that's where that came from.
Okay. Amen.
So we got A squared minus A minus 12, but it was subtracted, so it turns into minus A squared plus A plus 12.
That's where I got the. Wait, I'm really confused. Why are there two A squared?
Because one came from.
Oh, that's where it came from. Okay.
But I want to say a big thank you for paying attention enough to care what it's okay.
You are so very welcome.
So A squared minus A squared, how many A squares are left?
0.
None. So we just write A plus 12 on the top. And on the bottom,
minus?
A plus 3 and A. A squared minus A squared leaves no A squared left.
No, I was talking about the plus 12. What should do again?
She distributed it.
Distributed by minus, all the way through. Can any of that be factored?
Wait, I have a question.
Oh.
That A up there on A squared minus A squared plus A, is that supposed to be plus A?
Here's what I got right here, but it was minus this. So it turns into minus A squared minus a negative A, that's plus A, minus a negative 12 makes plus 12.
Is that the problem?
No.
This is the one we had to be quiet.
Why would she do it for us?
These are terrible.
So the two A squares on the top, do you just, do those just come out?
It's one A squared, take away one A squared, leaves no A squared. Distributed by minus, all the way through. So it turned into minus and negative 12.
Because I know you've been bleeding. Yes. Didn't you down the road? Oh, and it was from the.
Who dies from a nosebleed?
You
can hold it back and
Really?
Really?
If hardcore.
That's disgusting, you choke on
Your own nose blood.
Yeah.
That's what happens to people.
Oh,
in the
yeah.
cell.
You could choke on your own ear blood, technically.
Yeah, 'cause then they'll like lay back, and then it'll get stuck in your
It's not from your nose, it's
Like
from
that,
your chest.
people back out, they lay them like down so they can blow up, they can throw up here.
Then they'll.
Well, that's why you put heroin addicts, or like heroin, when you do heroin, you lay on your side. Because if you lay back,
Sometimes that girl
yeah,
make you mad.
if you lay back, you can choke on your vomit and die.
You really think
So
I can
don't-
make up one of these?
So don't do heroin, but if you do, don't lay on your back.
Do heroin on your side.
No, we already said don't do it. But if you are,
Or do it, but just do it on your side.
no.
Ow! My back. That's why.
If you really work on it and ask for help, you could finish this before you leave. That is your problem.
Oh, heaven.
It's not bad.
I have a question.
You write it on here.
You said, can we factor the box?
You're gonna have to factor the box.
Hey Alicia, would you mind stopping that? No, yeah, that's the one I want you to stop.
Huh?
No.
Nope, not right now. People are focused. Tough problem.
I was so close to doing it.
Just, we'll have to say that.
Indian corn?
I'm not gonna be here tomorrow.
I don't know what to do. I don't know what to do. That's a heavy thing.
Originally, I planned for us to be doing,
Welcome, take
Hey, I'm acting like I'm doing something.